Number concepts and operations. Number types. All numbers are real numbers. Natural numbers, integers, rational numbers, irrational numbers. Rational numbers are usually fractions, like 4/3, 10/11, and so forth. These are what? These are rational numbers. Then irrational numbers, these are numbers that cannot be expressed as an exact ratio of two integers, the likes of pi, √2, but 22/7, the approximate value of pi, is a rational number because it's a quotient of two whole numbers, 22 and 7. Therefore, it's a what? It's a rational number. Then we move forward to sets. Sets are represented by the square root sign, and here's how you read it. For example, if we have 5 there, you read it as the square root of 5. What does the square root sign mean? It's just a mathematical operator that gives you the number that you multiply together to get the number under the sign. What am I saying? If we have the square root of 36, the answer will be 6. How? In order to get 36, you have to multiply 6 by 6. That's what the sign means. And usually, sets are mathematical expressions containing the root of an irrational number, like we have been saying before, like √2, √7. These are all sets. And whenever we are simplifying sets, the goal here is to remain with what? With an irrational number. And there are cases whereby you do not get this, like you get square root of 9, square root of 16. Therefore, you just simplify it. Since it's exact, you get the integers, and you can simplify it there. But there are also other cases, like when you're given the square root of a decimal point number like 0.36, and you're told to simplify. Therefore, you can simplify that because it's exact. You have 0.6 there. Properties of sets. These are going to help us when we are simplifying sets. The first property is when we have two numbers multiplying themselves under the square root sign, we can distribute the square root sign to the numbers such that we have the square root of the first number multiplying the square root of the second number, depending on how many numbers we have. For example, if you have two numbers, in this case, the square root of the first number multiplying the square root of the second number. That's how you simplify the sign. Then we have the second property whereby we have a quotient of two numbers under the square root sign. You can distribute the square root sign to each number. The square root of the numerator divided by the square root of the denominator. Then we have a special case whereby we have the same set multiplying itself. Therefore, the answer will be what? The number under the square root sign. Like in this case, we have the square root of n multiplying the square root of n. Therefore, you get n. Simplifying sets. We want to simplify the square root of 162 and use the above properties. How do you do it? You find the smallest prime factor. In this case, 2 is the smallest prime factor. Then you divide 2. And the goal here is to find the prime factor that divides into the number given. 2 divides and gives us what? 81. Then the set now becomes 81 multiplied by 2. Then we break down using the above properties. We remain with root 81 multiplied by root 2. Root 81 is 9. Therefore, it simplifies to what? 9 root 2. Now we want to join 7 root 3 to make it under 1 square root sign. How do we do it? We first convert 7 to set form. How do you do that? We know that 7 times 7 gives us 49. Therefore, if we want 7 back, we say the square root of 49. Therefore, that's how we convert 7 to set form. Then we multiply root 49 multiplied by root 3. Then we join the missing properties above. Then we eventually end up with root 147. We now want to simplify sets under multiplication. Root 12 becomes root 4 times 3. 3 root 60 becomes 3 root 4 times 15. Root 14 becomes root 9 times 5. And root 4 times 3 becomes 2 root 3. Using the simplification methods which we have been using above. Then we break down 3 root 4 times 15. It becomes 3 times 2 root 15. How do we do that? 3 is factored out from the 3 root 4 times 15. Then we remain with what? the square root of 4 times 15. Then the square root of 4 is 2, therefore we get 2 root 15. Then root 9 times 5, we get 3 times root 5. Then multiplying all the whole numbers, 3 times 2 times 3 times 2, we get 36. Then under the square root sign we have 3 times 15 times 5, which we have collected from the sets. Then we eventually end up with 36 square root of 15 times 15. Then using the above properties, we know that if you are multiplying the same number under the square root sign, you get that number, 15 times 36, therefore we get 540. Now we want to simplify sets which are in fraction mode. Now using the above property, we know that we can distribute the square root sign to the numerator and the denominator. Therefore we have root 16 over root 7. Then root 16 is what? Is 4. Therefore we have 4 over root 7. Now in this form of simplification, we call it rationalizing. What do we call it rationalizing? We want the denominator to be a whole number, so that there will be, no set will remain on the denominator part. How do we do it? We multiply the numerator and the denominator by the denominator of the original fraction, which is in set form. Here we multiply by what? Root 7 over root 7. Therefore we get 4 root 7 over 7. And how did you get this 7 as the denominator? Remember, when you multiply a set by itself, we get the what? The number inside the set. In this case we have root 7 multiplied by root 7, therefore we get 7. In this case of simplification, the addition and the subtraction is involved. Then first of all, like we always do, we simplify the sets to their minimum form. Then 3 root 50 becomes 3 root 25 times 2. Then 5 root 32 becomes 5 root 16 times 2. Then 4 root 8 becomes 4 root 4 times 2. Then after simplifying, we get 3 times 5 root 2 minus 5 times 4 root 2 plus 4 times 2 root 2. Then multiplying with the integers, we get 15 root 2 minus 20 root 2 plus 8 root 2. Therefore in this case, now since the sets are now the same, we can now do our normal mathematical operations. So it's just 15 minus 20 and you get your minus 5. Then minus 5 plus 8, you get your 3. Therefore you get what? 3 root 2. In this form of simplification we have fractions multiplying each other. Then again, as usual, before we do anything else, we simplify. Now root 45 is what? Is the square root of 9 times 5. But the square root of 9 is what? Is 3. Therefore we end up with 3 root 5. Then the square root of 21 is broken down to 3 times 7. And we split, we get root 3 times root 7. Then as you can see, on top we have root 7 times 2 root 3. Therefore it cancels out. Then after it cancels out, we remain 5 times 2 over root 3 times 5. Then use the properties above. We what? We rationalize. How do we rationalize? We multiply the top, which is the numerator, and the denominator by the same set, which is what? Root 5. Root 5 multiplied by the numerator and root 5 multiplied by the denominator. Therefore you get 2 root 5 over 3. Highest common factors and lowest common factors. Here, when we say the highest common factor, what we mean is the highest number that can divide the given numbers without leaving a remainder. And the lowest common multiple is just the lowest number that is the multiple of all the numbers given. Finding HCF and LCM. Find the highest common factor of 28, 35 and 70. You express the given number in its prime factors. How do you do that? You divide the number repeatedly with the prime factors. You start with the lowest prime factor. In this case is 2. Therefore you divide by 2, you get 14. You divide again with 2, you get 7. Then you try to divide by 2, it cannot because it leaves a remainder. You go to the next prime factor, which is 3, it leaves a remainder. You go to the next, which is 5, it leaves a remainder. You go to 7, then 7 does not leave a remainder. Then you divide by 7, you get 1. Then after you divide by the number which gives you the answer is 1, you stop. Then you express the given number in terms of its prime factors. In this case for 28 is 2 times 2 times 7. Then you move over to 35. You try by 2, you cannot. 3, you cannot. Then 5, you can divide by 5, you get 7. Then again by 5, it leaves the remainder. Therefore you go to 7, you get 5 times 7 is the prime factors of 35. You move over to 70. 2 gives you 35. 5, 7, 7, 1. Then prime factors of 70, 2 times 5 times 7. Then taking all the common factors of the three numbers, we have 7 common in all the numbers. We do not have a 2 on 35 and we do not have a 5 on 28. 7 is only common in the three numbers. Therefore 7 is what? Is the highest common factor. Find the lowest common multiple. The tip here is you cannot go beyond the product of the three numbers. In this case, the product of the three numbers is 160. Therefore, your lowest common multiple must be less or equal to 160. Then you express the given numbers and you write down the multiples of the numbers until you get to a point whereby the three numbers have a common multiple. In this case, for 4, when you get to 40, you discover that as well for 5 you have the same what? The same multiple, and for 8 you have the same multiple. That's when you stop. And for 4, how you express the multiples, you say 4 times 1, you get 4 times 2, 8, and you continue incrementing the multiples. The same for 5, the same for 8. Then you discover that at 40 you have what? You have the common multiple. And if you can check, below 40 we do not have any common multiple for the three numbers. Then taking the common multiples, we have 40 as the common multiple, which is the what? The lowest common multiple. Decimal fractions and percentages. The fractions 5 over 8, 10 over 16, 15 over 24, they represent the same amount. They are equal. But 5 over 8 is the simplified form of the fractions. That is, 5 over 8 is the lowest terms of the three fractions. Recap. This is covered in CJC. It's just a recap. You can go through it. Now, we want to express fractions in percentages. And x percentage is short for what? For x of 100. What do I mean by x? X can be any number, for example 60. If you say we have 60%, it means it's 60 over 100. Then to change a fraction to a percentage, you multiply by 100. Then expressing 4 over 3 as a percentage, we say 4 over 3 times 100. Then we get 75%. To change a fraction to a decimal fraction, divide the numerator by the denominator. In this case, we have 5 over 16. We want to convert it to a decimal fraction. We do a long division on 5. 16 into 5 is 0. 16 into 50, that's 3. 3 times 16, we get 48. 48 subtract 50, we get 2. Then we drop down the 0. 16 into 20, that's 1. 1 times 16, 16. 20 minus 16, we get 4. We drop down another 0, we get 40. Then 16 into 40, that's 2. 2 times 16, 32. 40 minus 32, 8. We drop another 0. 16 into 80, that's 5. 5 times 16, 80. 80 minus 8 is 0. That's when we stop. Then the decimal fraction of 5 over 16 is what? 0.3125. Operators and rules of precedence. The rules of precedence adhere to BODMAS, which means whenever we have an expression, we first deal with the brackets, then division, then multiplication, then addition, and lastly subtraction. In this example, we want to simplify 36 divided by 4 times 5 in brackets 4 minus 2. Therefore, using our BODMAS, we first start with what? With the brackets, which is 4 minus 2. In 4 minus 2, you get 2. Then we move over to division. 36 divided by 4, we get 9. Then we go to multiplication. 5 times what? Times 2, that's 10. Then again we still have another multiplication. 10 times 9, that's 90. Then when adding or subtracting decimals, write the numbers in column with the decimal commas under each other. For example, we want to add 3.67, 40.234 and 10.00. Like I said before, you align the decimal commas. In this case, you just write the numbers down, but make sure that the commas are in line. Then you add, and after adding, that's what we get. Then when we are subtracting again, it follows the same format. Then when multiplying decimals, we first ignore the comma and multiply the given numbers as if they are integers. In this case, we have 1.1 multiplying 0.004. We multiply it as 4 times 11, then we get 44. Then we count the decimal places. How do we count them? We count the decimal places of the numbers which are multiplying each other. Which are these numbers? 1.1 and 0.004. In 0.04 we have what? 3 decimal places. In 1.1 we have 1 decimal place. Therefore, we have a total of 4 decimal places. Therefore, in our answer, we must make sure that we have 4 decimal places. Then when we are dividing, we first make the two numbers whole numbers. We find a multiple of 10 that we use to multiply the numerator and the denominator, just that both the numbers are what? Are whole numbers. Then we divide. In this case, we have 10.8 being divided by 1.2. Then we get 108 over 12. Then we get 9. Then we have directed numbers. These are positive or negative numbers. Actually, they are integers that are shown on what? On the number line. For example, if you want to add minus 4 plus 5, you go to minus 4. When you get to minus 4, since it's addition, you move 5 places forward from minus 4. And the number you land on is the answer. Therefore, you land on 1 is what? It's plus 1. Then plus 3 minus 1. Then you go to what? To plus 3. Then minus means you're going backwards. Then if you're going backwards, you go backwards. But since there's another minus, you're now going forward. A minus and a minus means plus. Therefore, you go forward. Therefore, you get what? Plus 4. Then we have minus 3 times minus 1. If we are multiplying two negative numbers, the answer is always positive. Then again, when we are dividing two negative numbers, the answer is always positive. Okay, now we are going to work out exam paper questions which are related to the topic which we have just learned. I will write down the details of the papers from which I took the questions. 0.8 plus 7.2 divided by 0.24. Then we use board mass here, because operator precedence must be adhered to. Therefore, we start with the division side. Say 7.2 over 0.24. Then we multiply by 100 to make the denominator and numerator whole numbers. Then we get 720 over 24. 12 into 24, that's 2. 12 into 72, that's 6. 2 into 60, that's 30. Then we replace the division part by 30. Then it becomes 0.8 plus 30. 0.8 plus 30. Then we use our theory such that we align the commas. We add a 0 after the comma. Then 0, 8. We make the commas in line. Then we add. From this it's clear it's 30, 8. Then that is our final answer. Find the exact value of that. Then we start with A. 0.04 multiplied by 0.3. From our theory, we deal with it as if they were integers. 4 times 3, we get 12. Then we count the decimal places. 1, 2, 3. Decimal places are 3, therefore we must have 3 decimal places after the comma. 1, 2, then it's 3. 0, 1, then 2. Then those are our 3 decimal places, giving us the final answer 0, 0, 1, 2. That's our final answer. Then we move over to B. We have 1.44 divided by 0.09. Then again we write it in fraction form. 1.44 over 0.09. And we find that integer value that makes the denominator a whole number, so that the division might be easier. Then that integer is 100. We multiply the numerator and the denominator by 100 and we get 144 over 9. Then we divide by 9. 9 into 9, that's 1. 9 into 14, that's 1. Remainder 5. 9 into 54, that's 6. Therefore, our answer is 16. Then we move over to C. 0.89 subtract 1.72, just to confirm. Then in this case, as you can see, we have the bigger number subtracting the smaller number. Therefore, we have the directed numbers here. Therefore, if you go on your number line, you discover that your final answer is going to be negative. But you cannot use our normal subtraction mode, whereby we have 0.89 on top. Therefore, we have to do it this way. But we must bear in mind that our answer must be negative. Therefore, whenever we have this form, the bigger number goes on top, the smaller number on the bottom. Then you subtract. Then after subtracting, your answer must be negative, since you are subtracting a bigger number from a smaller number. Therefore, you have 0.83, but our bigger number is negative. Therefore, it becomes minus 0.83. For the last questions, we start with A. Minus half, 1/2 multiplied by 4/5. Then we have a case of BODMAS here, which need to be adhered to. We do not have any brackets, we do not have any division. Therefore, multiplication takes priority. Then we start with the multiplication here. Multiplying 1/2 and 4/5. 2 into 2, that's 1. 2 into 4, that's 2. Then we get 2/5. Then we continue the operation. 2 minus 2/5. Convert 2 to an improper fraction. We have 5 as the common denominator. 2 into, we must multiply 2 by 5 to get that That's 2 times 5 minus 2. Then we get 10 minus 2 over 5. Sorry, over 5. Then we get 8 over 5. Then expressing as a mixed fraction, we have 1 and 3/5. Therefore, our final solution is 1 and 3 over 5. Then we move on to the second question. Here we are dealing with the highest common factor. Therefore, if you check here, 2 on the 2 columns, we have 2 to the power 3 is being common. Therefore, 2 to 3. Then we check again on 3. We have 3 being common, because here we do not have 3. We only have 3 squared. Then 3 is common everywhere. Then on 5 is common everywhere. We don't have 5 squared on the other 2. Therefore 5 is common. Then on the last one, 7 squared is common. We do not have 7 to the 3 anyway, except for that last part. And 7 to the 4 is only on the what? On the first one. But 7 squared is on everywhere. Therefore that is our final solution. The 2 to the 3, it simply means that we are multiplying 2 by itself 3 times. And 7 to the 2 simply means that we are multiplying 7 by 7. This is what it means, the index form, the 2 to the 3. Then you go to the last part. Sorry, last part D. Express that as a product of its prime factors. From our theory, remember that we divide the number using prime factors. We start with 2 since it can divide 248 without leaving a remainder. 2 into 248, we get 124. Then again 2 into 124, we get 62. Then again 2 into 62, we get 31. Sorry, we get 31. Then there is no other prime factor that can get into 31 that is less than 31. Therefore we use 31 now. Therefore we end there. And 248 expressed as the product of its prime factors, we have 248 being equal to 2 times 2 times 2 times 31. Therefore that is our answer, the solution to the first part. Now I want to find the number which is by which you can multiply 248 to make it a perfect square. Therefore, if a number is a perfect square, the number of prime factors must be equal. They must be even. For example, the number of 2's must be even, the number of 31's must be even. Therefore, what do we need? We must have 4 2's and 2 31's to make it what? A perfect square. Therefore, we add the two numbers needed to make it a perfect square. Therefore, here I'm highlighting the square root of the perfect square. the numbers which make up the square root of the perfect square. So if whenever you have a number of this form whereby the numbers of prime factors are even, in this case we have 2 4s and 2 31s like we have added here, therefore the number will be what? A perfect square. And the square root will be what? Will be 2 times 2. Here I have highlighted yellow, which means this will be what? Will be the perfect squares. Here I have highlighted the numbers we have added such that 248 will become a what? A perfect square. Therefore the number needed is 2 times 31, and that number is what? Is 62. So I was saying, if a number is supposed to be a perfect square, the number of prime factors must be even. In this case I've highlighted 2 times 2 times 31 in white and 2 times 2 times 31 in yellow. Therefore those numbers I've highlighted as white and yellow, they indicate that the factors make up a what? A perfect square, right? They make up a perfect square. Okay, so here I'm just illustrating the number that is going to be made up by adding 62. In fact, by multiplying 62 into the what? Into our original number, we get 376. That is the number that is represented by these prime factors. And the square will be what? These numbers I'm highlighting. The square root of the numbers. These numbers I'm highlighting. And it's what? 2 times 2 times 31. And it's what? It's 124 and the same here. So that will be the perfect square. So just to confirm if we've done something correct, then we multiply again 124 times 124 and we get 15,376. Therefore it checks out, it adds up. Therefore the number that needs to be multiplied is 62 to make it a perfect square. You find the value of that, giving the answer as a decimal fraction. .4 multiplied by 0.002. Then you treat them as if they were integers. 2 times 4, we get 8. Then you count the number of decimal values: 1, 2, 3, 4. Therefore, we must have 4 decimal places after the comma. You get 0, 0, comma 0, 0, 0, 8. Mind you, the 8 is also included in the number of decimal places when we count. It's part of that. There must be 8 in all. Sorry, there must be 4 in all. Then our last question is expressing that as a decimal fraction. Remember, in our theory we said you divide the numerator by the denominator. Here we're going to perform a long division. 16 into 5. That is 0. Then we add another 0 after the comma. And add a comma here. Then 16 into 50, that's 3. 3 times 16, that's 48. 48 minus 50 minus 48, we get 2. Then we add another 0 and drop it to make 20. 16 into 20, that's 1. 1 times 16, that's 16. 20 minus 16, that is 4. We add another 0, we drop it. 16 into 40, that's 2. 2 times 16, that's 32. 40 subtract 32, we get 8. We add another 0 and drop it. 16 into 80, we get 5. 5 times 16, 80. Then we get what? We get 0. Therefore, expressed as the decimal, it becomes 0,3125. Then expressing it as a percentage, you multiply the fraction by 100%. Get 500. 5 times 100, we get 500 over 16. Carry on with our percent. 16 into 16 into 15, that's 3. Remainder 2. Into 20, that's 1. Remainder 4. With a comma there. Remainder 4. We add a 0. 16 into 40, that is 2. Remainder 8. 16 into 80, that's 5. Therefore, the percentage is 31,25%.